Welcome to Module 3, Unit 1, which is about Atterberg limits. So Atterberg limits, depending on the moisture content, the behavior of the soil can be divided into four basic states: solid, semi-solid, plastic, and liquid. So the four basic states of the solid depends on the amount of moisture content. So the more moisture content, the more liquid the solid is. To understand further, we have here a diagram which we are about to consider. And notice that on the x-axis, you have your moisture content. So as the moisture content increases, the different state of the soil changes from solid to semi-solid, from semi-solid to plastic, and from plastic to liquid. So we observe that on this part, this is the portion wherein we have the least amount of moisture or amount of water. So on this state, that is considered solid. Now, if we will add water to it, from solid, the state of the soil becomes semi-solid. If we keep on adding moisture content again, from semi-solid, the state of the soil will become plastic. And then we add further moisture content, from plastic, the soil will become liquid. So these are the four states: solid, semi-solid, plastic, and liquid. And it depends on the moisture content. The moisture content in percent at which the transition from the solid to semi-solid state takes place is defined as the shrinkage limit. So we have here the four states: the solid, the semi-solid, the plastic, and the liquid. And in every transition, you call these the limits. So transition points, or these are the limits. The moisture content at which the transition from solid to semi-solid state takes place is defined as shrinkage limit. The moisture content at the point of transition from semi-solid to plastic is plastic limit. And then the moisture content at the point of transition from plastic to liquid state is liquid limit. So the limits are the transition points from the different states of the solid. So these parameters are known as Atterberg limits. So let's start with the liquid limit. Before we proceed, I want you to pause this lecture and go over and watch the procedure for the liquid limit test and the plastic limit test so that you would be able to understand it further. So go ahead and pause it and then resume this lecture after watching the procedure for liquid limit test and plastic limit test. So after watching the video, let's continue our discussion. So a schematic diagram of a liquid limit device is shown. This is the device. Sometimes this is known as Casa Grande apparatus. Casa Grande apparatus. This device consists of a brass cup. This is your brass cup. And a hard rubber base. So this is made of rubber. The brass cup can be dropped onto the base by a cam operated by a crank. To perform the liquid limit test, one must place a soil paste in the cup. So from the procedure that you had watched, you use the spatula to put the soil paste on the cup. And then after which, you use the groove to cut the paste that you had placed on the cup. Ito na yung magiging itsura after you have cut it. After operating the crank until some point wherein 1/2 inch has closed, you get a sample, dry oven it so that we can determine the moisture content. So by the use of the crank operated cam, the cup is lifted and dropped from a height of 10 millimeter. The moisture content in percent required to close a distance of 12.5 millimeter along the bottom of the groove after 25 blows is defined as the liquid limit. So by 25th blows, at least 12.5 has already been closed or nag-meet na yung dalawang portion ng soil paste. So the moisture content at that case is the liquid limit. It is difficult to adjust the moisture content in the soil to meet the required 12.5 millimeter closure of the groove in the soil path at 25 blows. Hence, at least 3 tests for the same soil are conducted at varying moisture contents with the number of blows required to achieve closure varying between 15 and 35. So it is possible but it is difficult, so tsambahan. But it's okay kasi hindi exactly na 25 blow ay nakapag-close ng 12.5 millimeter. So what is done in the laboratory is to do 3 trials and then graph the trials, and then from there we can project to get our value of liquid limit. So the moisture content of the soil in percent and the corresponding number of blows are plotted on semi-logarithmic graph paper. The relationship between moisture content and the log of n is approximated as a straight line. So on the y-axis, you have your moisture content, and then on the x-axis, you have your number of blows. But note that on the x-axis, this is a semi-log scale. So we see here that there are 1, 2, 3, there were 4 trials that were performed in the laboratory. So you plot the 4 trials. So this is the number of blows and then its corresponding moisture content. After that, you connect the points together, and the straight line that was formed is, you call that your flow curve. So after that, we project the value of n at 25th. So project it going towards the flow curve to where it intersects the flow curve. We project it towards the moisture content. We get the reading at this point. This is now our value of liquid limit. So the line is referred to as the flow curve, as mentioned a while back. The moisture content corresponding to n is equal to 25, determined from the flow curve, gives the liquid limit of the soil. Flow index, this is the slope of flow curve or the flow line. So if this is our flow curve, you have here your slope. That is your flow index. So flow index is designated as I's of F, which is equal to W1 minus W2 divided by the logarithm of the quantity N2 divided by N's of 1. We also have a one-point method. So this is applied when there is only one test that was run. So that is liquid limit is equal to W's of n multiplied by n divided by 25, the quantity raised to tangent beta. So n is the number of blows in the liquid limit device for a 12.5 millimeter groove closure. W's of n is the corresponding moisture content. And then tangent beta is equal to 0.121. But note that the tangent beta is not equal to 0.121 for all soils. Next is the plastic limit. The plastic limit is defined as the moisture content in percent at which the soil crumbles when rolled into a thread of 3.2 millimeter in diameter. So you have watched a while back portion of soil that is being rolled. So that is 3.2 millimeter diameter. After forming a thread of 3.2 millimeter in diameter, and the soil doesn't crumble, meaning to say there is too much moisture content, so try to add dry soil. So the plastic limit is the lower limit of the plastic stage of the soil. The plastic limit test is simple and is performed with the repeated rollings of an ellipsoidal-sized soil mass by hand on the ground grass plate. So this is illustrated also in the video presentation. Alright, on the picture, ganito ang itsura niya. Kapag niroll mo na siya at nag-crumble, so you can get a sample and put it in the oven dry for you to determine the moisture content. Next is the plasticity index. Plasticity index is simply the difference of liquid limit and the plastic limit. So that is simply Pi minus L. Pi is equal to liquid limit minus plastic limit. And then we also have your liquidity index. This is the ratio which defines the relative consistency of cohesive soil in the natural state. So L of I is equal to water content or moisture content minus plastic limit divided by liquid limit minus plastic limit. But what is this? This is your piece of I. So liquid index is equal to moisture content minus PL divided by PI. where W is the in situ moisture content. This table shows the plasticity index in the qualitative manner as follows. So when your PI is 0, meaning to say the soil is non-plastic. If your PI ranges from 1 to 5, the soil is slightly plastic. When the range of PI is 5 to 10, the soil is said to be low plasticity, and so on and so forth. If it is greater than 40, meaning to say it's very high plasticity. So note that if liquidity index is greater than 0 but less than 1, that is in plastic state. If liquidity index is greater than 1, that is in liquid state. And then finally, you have your consistency index. This is commonly used for engineering purposes. So consistency index is the liquid limit minus the moisture content divided by the liquid limit minus piece of I, or plasticity index. We go to examples. Result from liquid and plastic limit test conducted on the soil are given below. So we have here the liquid limit test, the number of blows. So at n is equal to 14, the moisture content is 38.4. At n is equal to 16, corresponding moisture content is 36.5. When n is equal to 20, the moisture content is 33.1. At n is equal to 28, the moisture content is 27.0. Also, on the plastic limit test, it is found that plastic limit is 13.4%. So letter A, draw the flow curve and obtain the liquid limit. Letter B, what is the plasticity index of the soil? And then we are to determine the liquidity index of the soil in this problem, given that moisture in situ is 32%. Okay, so first is we have to obtain the liquid limit. And how do we obtain that? We have to draw the flow curve. Okay, so again, on the y-axis, that is your moisture content. On the x-axis is the number of blows. So remember that this is in log scale. So these are the given. So we plot when n is equal to 14, the moisture content is 38.4. So we plot that on the table. N is equal to 14, moisture content is 38.4. So that is sample 1. Next is when n is equal to 16, moisture content is 36.5. That's the second sample. And then third, when n is equal to 20, moisture content is 33.1. And then finally, when n is equal to 28, moisture content is 27.0. So you have plotted the 4 samples or the 4 trials that were obtained in the laboratory. So the next one is to draw your flow curve by connecting the lines together. So this is now your flow curve. Next is we are to determine our liquid limit. So we said that liquid limit is the moisture content corresponding to n is equal to 25. So this is 21, this is 28. Somewhere in between is 25. So project n is equal to 25 to where it intersects the flow curve. We project it towards the moisture content. And then we get the reading. That is now the value of your liquid limit. So liquid limit is equal to 29. So the next question is to get the plasticity index. So the plasticity index is equal to the liquid limit minus plastic limit. Plastic limit is given. So PI is equal to 29 minus 13.5. PI is simply 15.6. Next is to determine the liquidity index of the soil in the previous problem, given that moisture content in situ or in its original state is 32%. So working equation, liquidity index is moisture content minus plastic limit divided by liquid limit minus plastic limit. So we simply substitute moisture content is given to be 32 minus our plastic limit. It's also given 13.4. And then liquid limit, we read it from the graph that it's 29 minus plastic limit. So this is simply 1.192. So this is greater than 1, meaning to say this is in liquid state. If Li is greater than 0 but less than 1, plastic state. Li is greater than 1, liquid state.